Today's lesson is going to be a little hefty, all right? So we're gonna have lots of word problems. I'm just trying to warn you. So you'll need to like get all your focus energy here with me. And I'll walk you through these. I'll give you, I found a really nice technique that I like to deal with these problems. So hopefully that will help you. And we'll work through it together. Okay. Also, you picked up the focus problems on your way in. That's going to be your homework tonight. Okay. The first one's super quick. It's just asking like, what's your given? What do you need to find? And what's the equation? And then you're solving 2 and 3. Okay. So there's really 2 equations to solve. And the other one's quick. All right. So also, any Monsters Inc. fans? You guys know Monsters Inc.? Yeah, it's really cute. Anyway, I'm like, dig deep. Okay. So I thought this was kind of funny. You ready? Ready for calculus. Okay. I thought it was funny that the method to solve these problems was called DREDS. Like you dread it. Anyway, it's not spelled like dread, like EA, but I'm like, I think it'll be easy to remember because we dread these. No, hopefully you don't dread these. This will help us not dread them. Okay, so a little acronym is the first thing we do is to draw a picture, right? Draw a diagram or draw a picture. Oops. Okay, draw a picture. Label what you know and what you need to find. You want to ask yourself, hey, what is my ultimate goal? Okay. The next thing for R, it's all about the rates. You're going to list and label all of your known and unknown quantities. Is it being really laggy today? There it is. Next, find an equation that relates the variables. Hey, these are related rates. So with all your variables, you want to think, okay, what formula do I know? Likely from geometry, it's going to be like volume, area, surface area, maybe volume of a cube. We're going to be using all that kind of stuff now. What relates those variables? Then you're going to differentiate or take the derivative, right? Differentiate with respect to time. So you write only dt over dt is not needed, but you're not going to have any t's in there. So you write whatever you have, dv over dt for volume, dA over dt for area, dr over dt for radius. We talked about that the other day. Finally, substitute in all of your known quantities. Whoops, I did not spell that right. Substitute. Okay. And then make sure you use proper units in your final answer. Okay. Right. Here we go. We ready? Oh, did I get too fast? There it is. Okay. All right. Example 1. Here we go. A pebble is dropped into a calm pond, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area, A, of the disturbed water changing? Give the exact value or round to the nearest hundredth. Okay, so when you read through a word problem, you're kind of like, it sounds like wah, 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 Charlie Brown's teacher. Like that's how I always was. So I have resigned myself when I read a word problem, even to this day, I know I have to read it twice. That's just how my brain works. That might not be how your brain works. But when I read it, The first time I'm just kind of like, okay, let me just try to orient myself to this problem. The second time I really kind of dig in and I'm going to underline some things and I'm going to maybe try to draw a picture, label what I know, and think, what am I asked to find? Okay. So we have a pebble dropped into a calm pond causing ripples in the form of concentric circles. You know what concentric circles are? Like they look like this, right? You know, throw a pebble in a pond, looks like that. They go up. And then the radius R of the outer ripple is, watch this, increasing at a rate of 1 foot per second. Ladies and gentlemen, increasing means positive or negative? Positive, okay? Rate means what in calculus? Rate means it is a derivative, right? It's a differential. It's okay. Yeah, it's a differential of time. So this means it's going to be like a derivative. So if I'm talking about the rate of the radius, what variable is that? The rate is the derivative of the radius, dr, with respect to time, dt, right? Does that make sense? dr over dt. The rate of the radius, rate of change of radius, derivative of radius with respect to time. Okay, then, so that means in my picture, this like outer ripple is, I might write dr over dt is 1 foot per second. When you see units like foot per second, something per minute or whatever, that's going to be your differential, okay? Your d something over dt. And I'm going to make a note that it's positive because it's increasing. Okay, next, when the radius is 4 feet, at what rate is the total area changing? Okay, so I can make, okay, my radius is going to be r equals 4 feet. Okay, so I'm going to, this is the first part of DREDS. We drew a picture and labeled. Okay. Finally, we're going to like deal with all of our rates, right? We want to say, okay, I kind of listed some. I know dr over dt is 1 foot per second. I also know my radius r is 4 feet. And I also want to know, what am I asked to find? Do you guys know what they're asking me to find here? Well, they're saying at what, what's that? Never mind. Okay. At what rate is the total area changing? Can anybody tell me what I'm asked, what variable I'm asked to find? Rate, area changing. What's that? dA over dt. Yeah. Rate of change of area means derivative of area with respect to time. Yeah. Because all of this, if you give it more time, is going to change. So the area dA over dt. So I always write find d over t. This is my goal. This is my goal. Okay. So we did, for DREDS, we did draw a diagram, we did rates. Now it's time to think about an equation that relates all these variables, these related rates. Okay. So normally we're going to have to think back to probably some geometry equation. What geometry equation do you know that might relate radius and area? Yeah. A equals pi r squared, area of a circle, right? So the area of a circle is pi r squared, okay? And I'm soon going to outline I want you to make a note card of like your common formulas. I'll have you guys do that. That'll be really helpful too. So then area of a circle is pi r squared. It says with the equation, you find your equation, and then next, what do we do with that equation? Differentiate, take the derivative. So step 4 is take the derivative. Okay, so we're going to do d over dt, the derivative of area with respect to time. Yeah, you can just, I usually just put d over dt of the whole thing and I put it in brackets. I know I'm going to derive both sides. Okay, I look at it and I think, okay, what calculus rules do I need? Do I need to use product rule or anything like that? No, I have one variable here and one variable on the right. Okay, so remember pi is just a constant. You just treat it like a number. So my derivative of a is going to be dA over dt. That's just one, right? 1 d over dt. And then derivative of pi r squared, bring the 2 in front. So it's going to be 2 pi r. And I need to write what differential? dr over dt, because I took the derivative of r. So far, so good. Okay. Now, the next part of DREDS is to substitute in. We're almost there. So step 5, sub in all known quantities. And hopefully you have them all. And in this one, this is more of a basic example. So they're all going to be there. And by basic, I mean, it's still hard, but okay. So you plug in dA over dt is what you're supposed to find. So you'll leave that as a variable. 2 pi is just a number. R, I'm going to plug in as 4, right? I know that's 4 feet. So 2 pi times, oh, sorry. 2 pi times 4 for R, and dr over dt is 1. Okay. Now, dA over dt is going to be, okay, in the directions I said, hey, either give me the exact value or round the nearest hundredth. I want you to be able to do both. On the quiz, I'll most likely accept anything. So I have 8 pi, and then that's my answer, right? Because am I finding the rate of change of area here? Does dA over dt give me what I want? Yeah. Now I need to know units. Did anyone take a stab at the units? Yeah, Cassie? Feet squared per second. Remember, it's the units of y, so in this case, a, over the units of t, right? Units of what's on top over units of what's on the bottom. Feet squared per second. Now, there's another way that you can figure out units. Like if you actually put them in when you plug in, radius is 4 feet. Just watch this. This might help your brain. And 1 foot per second. Do you see how you get with the units feet squared per second? So that's another way you can do it. But I usually just think, what are the units for area? Feet squared. And then time in this problem is seconds. Okay. And so if I go ahead, you can get your calculators handy for today. You'll need that. If I pop that in on the calculator, I get 8 pi is about 25.13 feet squared per second. Okay, so whichever one you want to do, but go ahead and write them both since we're in the notes. Okay, do you guys have any questions on that? How does it feel on your end? How are you feeling? We're feeling good about this one? Okay, awesome. That's great. And just so you know, like, I don't want to make the test super hard. Like, I'm going to do ones that I really commonly ask you about, like an area one. And I'm going to have to throw a volume one in there too, because you'll definitely see those. Okay, let's try this one. Now, this one is a little bit more difficult. Okay, so I'm choosing to do a more difficult one with you with volume. And tonight I'm going to let you try an easier volume problem for homework. Okay. So let's do a harder one and see how you react to it. Okay. All right. Water is draining out of a conical tank. The radius is changing at a rate of 2 inches. Oh, yes, I wanted to tell you. I'm so sorry. If you look at example 2 and your 2, they're the same. I forgot to change the one problem. So, you don't have to write it down. You can maybe take a picture of it, or, like, if you really want to reprint it, you can, I don't know, just maybe write basic ideas down. Okay. Yeah. Okay. So, and you'll have my video for this too. Okay. Water is draining out of a conical tank. The radius is changing at a rate of 2 inches per minute. And the height, for this cone is defined as H equals 3R. Find the rate of change of the volume of the cone when the radius is 6 inches. Okay, we read through it. We know we're dealing with a cone, okay? So I'm gonna go back through, I'm gonna say, okay, it's a conical tank. This is your first hint. This is the hint. Because that kind of tells me maybe what equation I might be using, right? Okay. The radius is, changing. Remember, calculus is all about the math of changing things. So changing at a rate of 2 inches per minute. Is that R equals or dr over dt equals? If I say changing at a rate of change of radius is, that is dr over dt. Do you see the difference? Rate of change, as soon as you see that trigger word, that means derivative. You need to associate rate of change with derivative. So it's draining. So radius is changing at a rate of 2 inches per minute. Now, I have to ask myself, is this positive or negative? What do you think? You think it's negative? Tell me why. It's draining, right? So, and this is it positive or negative? So you have to actively think about that. So it's telling you the water is leaving, so we're subtracting. So my rate is actually going to be -2 inches per minute. Do you see that little tricky thing there? So when you see decreasing, right? I had you guys write out, you remember me telling you to write out what this means, right? This -2 feet per second. Oh, it means it's decreasing at a rate of, right? I had you guys write those out a lot because I knew this was coming, okay? So, and I also know the height is defined as H equals 3R. Find the rate of change of volume when the radius is 6 inches. Okay, so I also know R equals 6. What am I asked to find? The rate of change of volume. That means dV over dt, right? I also know H equals 3R, okay? Let me draw I did this a little backwards. I did maybe step 2 of DREDS. I did my rates first, but I like to do that. That's kind of how my brain works a little bit sometimes before I draw. So we're gonna draw the picture. So we have a cone, a conical tank. Okay, water's in here. Yay, got some water. And I know that my radius is 6 inches. I know that my height is 3R. It's really great that it gives you H in terms of R because you're going to have 2 variables in the volume equation for a cone. And so that it puts it in terms of 1 variable. That's what it's going to help you with. And then do I know anything else? I know it's a rate of, so what I would do to remind myself that it's a negative rate is water is draining. I put kind of like a direction, like where it's what the object is doing. It is, and since I'm not an artiste, I just choose like little arrows. So this dr over dt is draining at -2 inches per minute. Okay. Is everybody so far so good? Okay. Now, the next thing is write your equation. What's an equation that relates volume, radius, and height? Well, you probably think, oh yeah, volume of a cone, right? Does your mind jump to that's what I'm gonna have to use? No? Okay, when you see volume, here's what your brain should jump to. I'm probably going to have to use a volume equation from geometry. Okay. Then you think, yeah. So then you think, okay, what shape do I have? Cone, volume of a cone. What's the formula? Okay. So I don't expect you to have this memorized right now, but so I think I might be gentle and not make you memorize it. I might have you make a note card and let you use your note card. But I will tell you that your college professors will expect you to have them memorized. I'll go over them. And I think I might do that tomorrow because I didn't make a slide for it yet. So yeah, well, that'll be one of the things that we do tomorrow. So the volume of a cone is 1/3 pi r squared h. I saw like different ways to think of it. Like a cone, if you think like cylinder is like 3 cones. So it's like, volume of a cylinder is like pi r squared h. So it's like 1/3 of the volume of a cylinder. If you think of it that way. Anyway, that's the formula. So now do you see how all of these rates are going to be related in this equation? Okay, that's one of the harder parts. You like kind of have to like pull that equation out of nowhere. So now that we have our equation, what do we do next? DREDS. We differentiate, right? So derivative. So we're going to do derivative of volume with respect to time, d over dt of this equation. But, oh, actually, I'm sorry. Wait, before we do, think ahead. I'm sorry. Before we derive, we can simplify. Because what would I have to use with this? Do you see product rule with R and H? Do I want to use that? Do I have to use it? No. Look. Look at this. H equals 3R, right? Couldn't I just use algebra and plug it in? Do you see that? I'm going to take, so before I differentiate, I'm going to simplify. So simplify. Okay, so the volume is 1/3 pi r squared times h is 3r. It tells me that in the problem. And then I can say this is, ooh, check out what happens. What cancels? The 3. Yeah, and then 1/3. That's nice. And then what does this simplify to? V equals pi r cubed. Yes? Any questions? Okay. I'm giving your brain some time. I'm trying to like pause as much as possible. I know it's like your brain's going like a mile a minute. So. Okay. All right. Are we ready to differentiate? Now this is much easier to derive. Okay. So now we're going to do differentiate in DREDS. So we do d over dt, the derivative of volume with respect to time. So we have dv over dt equals, bring the 3 in front, power rule, 3 pi r squared. And we also need what? dr over dt, because I just derived r. Okay. And now it's going to be easy. We just plug in. Okay. So we sub in. So we get d. We're solving for what? We're solving for volume, right? So this is going to be our variable. So 3 pi r is 6 inches squared. And dr over dt is -2 inches per minute. And we simplify. So we get dv over dt is negative, what is that? 36 times 3, wait, 36 times 3 times -2 pi. -216 pi. You can use your calculator. I mean, you don't have to put that in hand.
Big brain.
Big brain. Okay. All right. And then what are my units? It's
Inches squared.
lagging. Inches square, inches, careful. What are we solving for? Units of volume over units of time. So inches cubed over, what's my time in here? Minute, yeah, per minute. Okay, so that's an exact value. And my rounded value, I would just pop it in my calculator. So I would say, hey, whoops, negative 216 pi is negative 678.58 inches cubed per minute. Okay, so either one is good there. Okay, what do you guys think of that one? How are we doing? Are your brains mush yet? Okay. In your minds, what is the difficulty level of these problems compared to like stuff we've done? Huh? Not horrible? That's good. I'm so glad. Okay. You ready to try one? That's the spirit. Well, yeah, have to anyway. All right. So this is your turn too. It's easier than the one I just did, I promise. So give it a shot. I'm gonna pause the video here. Okay, so if you were wondering the formula is volume of a sphere is 4/3 pi r cubed. Okay, so you can continue if you were onto something but didn't have the formula. Okay. So air is being pumped into a spherical balloon. That's my hint. Balloon, it's a 3D object at a rate of, okay, as soon as I see rate, I know that's d something over dt. 4.5, hey, check it out. Check out these units. That's a hint. Cubic feet per minute, okay? And then find the rate of change of radius. I'm finding another differential rate of change when the radius is 2 feet. Okay, so I have a balloon. I am pumping. Let's see, I have a pump. And I'm pumping some air into it. It's expanding at a rate of 4.5 cubic feet per minute. What variable does cubic feet per minute go with? Well, feet cubed per minute goes with volume. And since it's a rate of change, dV over dt is 4.5 cubic feet per minute. Okay. Does that make sense? If you see squared feet per minute, guys, squared feet per minute, what do you think that would be? Squared is area, right? So then I also know that my rate is positive because it's expanding, yes? I want to find, oh, let's also what I know. I know the radius is 2 feet. Okay. I want to find the rate of change of the radius. So dr over dt. That's my goal. Okay. The next thing we're going to do is we got our equation, volume of a sphere. We take the derivative with respect to time. There's no product rule, so we just derive dv over dt. No. Oh, great question. Hey guys, I had a really good question. I got a question. Hey, do I simplify it and put the 2 in right now? If it's the r is like a constant, it's not like a differential, I'm not going to plug that in until I take my derivative because I need my dr over dt. Okay. So dv over dt equals, bring the 3 in front, 3 times 4/3 pi r squared. The 3's cancel. You also want to write dr over dt because you took the derivative of the radius. So you get 4 pi r squared. See ya. dr over dt. And then we plug in dv over, oh, sorry. Okay. Did you catch that dv over dt is 4.5 here? 4 pi, and then the radius is 2 squared. And dr over dt is the one we're trying to solve for. So that stays alone, okay? All right, so we get, well, this is 16, I'm looking at this part. 16 pi dr over dt equals 4.5. Divide by 16 pi. Hey, in my calculator, here's what I do. I leave the pi out of it to get an exact value. I do 4.5 divided by 16. And I get math as a fraction. And I get 9 over 32 pi. Okay. And my units are dr over dt is feet for r, per time is minute, right? Feet per minute. If you plug that in the calculator, you get a value for it. I said round to 4 decimals, 0.0895 feet per minute. Okay. For the focus problems, you will need to know the area of a circle and the volume of a sphere, which we did in the notes, so you should be fine. Okay? You too.